Welcome to the latest episode of the FilmTalks podcast, created by AI at Studio 86 in Stockholm, Sweden, where we explore the ideas, innovations, industries, technologies, and global stories shaping the future of our world. Today, we're exploring one of the defining environmental and industrial challenges of our time: plastic, circular economy systems, sustainability innovation, and the global movement attempting to rethink the future of materials.
Exactly. And it's such a massive topic to tackle.
It really is. And before we really dive in, I want you, the listener, to just think about this scenario for a second. Right now, down in the absolute deepest part of the Mariana Trench.
Oh, yeah.
Right. Nearly 36,000 feet below the surface of the Pacific Ocean. It's a place so remote, so freezing, and just completely crushed by hydrostatic pressure. I mean, more human beings have walked on the surface of the moon than have visited its bottom.
Yeah, it's basically an alien world down there.
Exactly. And yet, sitting down there in the pitch dark, there is a plastic grocery bag.
It's just staggering when you think about it.
It is. How did a material that was originally invented to literally save humanity from material scarcity end up outliving us at the absolute bottom of the ocean? So we are going to trace that entire journey today. We're looking at the high-tech innovation ecosystems of Sweden, including, pioneering engineering firms like AFRY, and we're connecting those sterile European laboratories all the way to the coastal resilience efforts happening right now on the front lines in places like Tulum, Mexico. And then we're going to tie it all together with ESG financial frameworks and, honestly, the incredible behavioral shifting power of documentary storytelling.
Which is really the only appropriate scale at which to view this issue, right? I mean, if we start this conversation by simply pointing at a littered beach and saying, plastic is pollution and we need to clean it up, we are completely missing the actual story.
Right. It's so much bigger than that.
It is. The narrative of plastic isn't just a story about picking up trash. It's a story about global economics, supply chain dependencies, and these intricate, often completely invisible systems that dictate exactly how modern civilization functions.
Yeah.
We are talking about a massive, truly unprecedented global transition here. We are attempting to move from a deeply entrenched take, make, waste philosophy, which has basically defined the Industrial Revolution for the last century and a half, to a society that has to figure out, literally on a molecular level, how to become completely circular.
A total rewiring.
Exactly. It is a fundamental rewiring of the physical economy.
Okay, let's unpack this. To understand how we rewire that economy and how we actually, replace or manage this material, we really have to look at why it became so ubiquitous in the first place.
We do. You can't solve the problem without respecting the history.
Right, because I think there is a tendency to look at plastic as this inherent villain, like it's just this toxic mistake of history. But plastic is essentially a victim of its own success. It's an indestructible superhero material that we bizarrely decided to use for things meant to be thrown away after 5 minutes.
Yeah, it's madness.
But when you look back at its origins, plastic was an extraordinary, revolutionary invention that quite literally saved certain natural ecosystems from being completely decimated.
It truly was. I mean, let's go back to the early 20th century for a second.
Okay.
Before the invention of fully synthetic plastics like Bakelite in 1907, human manufacturing was entirely bound by the constraints of natural materials.
Right, whatever we could grow or mine.
Exactly. If you wanted to make a billiard ball or a piano key or a hair comb, you needed ivory, tortoiseshell, or horn. We were literally hunting species to the absolute brink of extinction just to manufacture everyday consumer goods.
Wow. We don't even think about that today.
No, we don't. And think about the alternatives. Wood rots, right? Metal rusts, and is incredibly heavy and energy-intensive to forge. Glass shatters easily, and it's terribly expensive to transport because of its sheer weight.
Yeah, shipping glass is a nightmare.
Exactly. And then out of nowhere comes synthetic plastic. It completely liberated human manufacturing from the constraints of nature. It was incredibly cheap to produce. It was infinitely moldable, durable, flexible, lightweight, and most importantly, it was highly scalable.
So it was basically a miracle material at the time.
It was. For decades, plastic wasn't a villain. It was the ultimate symbol of democratization and progress. It meant that everyday people, not just the elite, could afford goods that were previously reserved for the
And
wealthy.
it totally transformed human life in ways that, we take completely for granted today. I mean, just think about the medical field.
Absolutely.
The introduction of single-use, sterile plastic tubing, IV bags, syringes, incubators, it completely revolutionized patient safety. Before plastic, medical instruments were glass and metal.
Then you had to constantly boil them.
Right. They had to be constantly sterilized, which carried massive, massive risks of cross-contamination. Single-use plastics drastically dropped the rates of hospital-acquired infections.
It saved millions of lives.
Exactly. Or think about the global food supply.
Yeah.
Plastic preservation things as simple as a vacuum-sealed film dramatically reduced food waste globally by extending the shelf life of perishables. Food could suddenly survive the journey from a rural farm to a grocery store halfway across the world without rotting in transit.
Yeah, and we really cannot overstate the impact it had on global transportation and the carbon footprint of logistics either.
Oh, right, because of the weight.
Precisely. The lighter a vehicle is, the less fuel it consumes. Modern aircraft, like the Boeing 787 Dreamliner, they are made of up to 50% composite materials, including these incredibly advanced carbon fiber reinforced plastics.
Wow, 50%.
Yeah. This makes the plane significantly lighter than older aluminum models, which means it uses about 20% less fuel. Over the lifespan of a single commercial jet, that equates to millions of gallons of jet fuel saved and millions of tons of carbon dioxide kept out of the atmosphere.
That's a huge carbon offset just from using plastic.
It is. The acceleration of global supply chains over the last century simply would not have been possible without the lightweight durability of plastic packaging and components. It drove the cost of manufacturing and shipping down to fractions of a cent, connecting the global south to the global north in this unified economic web.
But, here is the grand paradox of the 20th century. The exact properties that made it a miracle are what doomed us.
What's fascinating here is how the scale of production vastly outpaced global waste management capabilities. That's the core tragedy of our material design. The very properties you mentioned, its extreme durability, its resistance to bacteria and degradation, and its near zero cost, are exactly what created this long-term global disaster. We engineered a material with these incredibly long, complex synthetic hydrocarbon chains.
And nature just doesn't know what to do with them.
Exactly. Mother Nature simply does not possess the enzymes or the biological mechanisms to break those specific carbon bonds. So it doesn't biodegrade. It doesn't disappear into the earth to become nutrients for something else. It simply accumulates.
It just sits there or floats away.
Right. It travels on wind and water currents, and over time, instead of biodegrading, it photodegrades. It's battered by wave action and ultraviolet light from the sun, and it just fragments. It breaks into smaller and smaller pieces, creating microplastics.
Which are literally everywhere now.
Everywhere. These microplastics are now so pervasive that they're infiltrating the entire global water cycle. We are finding them in the rain, in the snow on Mount Everest, inside human bloodstreams, and as you mentioned at the start, at the bottom of the Mariana Trench.
It's terrifying. And because it was so cheap to produce, the modern economy just became completely addicted to low-cost, disposable materials. We built a society that optimized for convenience above absolutely everything else.
Convenience became the ultimate metric.
Yeah. I mean, why wash a glass bottle when you can manufacture a plastic one for a fraction of a penny, drink the water in 3 minutes, and toss the bottle away?
And because of that massive economic incentive, the sheer scale of global virgin plastic production just exploded. We went from producing a couple of million tons a year in the 1950s to over 400 million tons a year today.
400 million tons annually.
Annually. That volume vastly outpaced our global waste management capabilities. And that is the crux of the transition we are talking about today. The conversation has to completely shift away from the end consumer's behavior.
Right, because you can't just recycle your way out of that volume.
Exactly. You cannot just organize a beach cleanup on a Saturday morning and solve the problem, because the industrial tap is still running at maximum volume. We have to pivot from viewing this as local litter to recognizing it as a systemic global scale crisis. It touches geopolitics, macroeconomics, and public health.
Which perfectly brings us to the physical reality of what actually happens to this material. Let's trace the hidden veins of the global waste system.
Let's do it.
Because for everyone listening right now, I want you to think about what you did this morning. Maybe you finished a bottle of water, or you emptied a plastic clamshell container of berries, you rinsed it out, and you tossed it into a blue recycling bin.
A very familiar routine.
Right. Most of us never think about what happens after that item leaves our hands. It's out of sight, out of mind. We feel a brief hit of dopamine because we did the right, environmentally conscious thing.
But waste does not disappear just because the garbage truck drives away.
Yeah.
The end of life for that plastic bottle is actually just the beginning of a highly complex, deeply flawed, and honestly incredibly opaque global network.
Opaque is the right word for it.
Yeah. When you put that bottle in the bin, it enters an international web of materials recovery facilities, giant waste management conglomerates, cross-ocean shipping routes, foreign ports, and global energy systems. It literally becomes a traded commodity.
So let me ask you this directly. On behalf of everyone listening who diligently separates their plastics, washes out their peanut butter jars, and tries to follow the rules, when you or I toss a plastic bottle into a blue recycling bin, are we just participating in an illusion? Are we just shifting our own guilt into this massive international shell game?
That is the uncomfortable, necessary question we all have to face right now. And the answer historically has overwhelmingly been yes.
Wow. Just a flat yes.
Unfortunately, yes. It is largely an illusion. The traditional mechanical recycling model is fundamentally breaking under the pressure of rising consumption and this insatiable demand for flexible, multi-layered packaging. The reason the blue bin feels like an illusion is because of the massive disparity in global infrastructure, combined with the chemical reality of the material itself.
Okay, let's break both of those down. Start with the chemical reality. Why doesn't mechanical recycling work the way we think it does? Like, when I recycle an aluminum can, it can become another aluminum can forever, right?
Correct. Aluminum and glass can be melted down and reformed infinitely without losing any of their structural integrity. Plastic cannot. Traditional mechanical recycling is like making a photocopy of a photocopy.
Oh, that's a great way to put it.
Yeah, every time you chop up a PE plastic bottle, melt it down, and reform it, the heat and physical stress shorten the polymer chains. The plastic degrades. It becomes brittle. So a clear plastic water bottle usually doesn't become another clear plastic water bottle.
So what does it become?
It gets downcycled. It becomes polyester fiber for a cheap fleece jacket or maybe plastic lumber for a park bench. And once it becomes a fleece jacket, it cannot be recycled again. It just sheds microplastics in your washing machine and eventually goes straight to a landfill.
So mechanical recycling doesn't actually prevent plastic from becoming waste.
Not at all. It merely delays its trip to the landfill by one single life cycle.
Man, that is bleak. And then there's the infrastructure side you mentioned. We think it's being processed in our own cities, but it's often not, is it?
Exactly. You have advanced, wealthy nations generating enormous volumes of plastic waste, but they completely lack the domestic industrial capacity to process all of it economically. Labor is expensive, sorting is incredibly difficult, and virgin plastic, which is heavily subsidized by the fossil fuel industry, is almost always cheaper for a manufacturer to buy than recycled plastic.
Right, because of cheap oil.
Yes. So for a long time, the economic solution was simply waste exportation. We shipped our recycling off to developing economies. For decades, the West sent millions of shipping containers full of plastic waste to China. We essentially outsourced our environmental footprint.
Out of sight, out of mind. Until China implemented the national sort policy in 2018 and flat out banned the import of foreign plastic waste.
Exactly. And when China closed its doors, the global recycling market collapsed overnight. The West suddenly realized they had absolutely no idea what to do with their own waste. So the waste simply shifted, moved to other countries in Southeast Asia or Africa or Latin American nations that often struggled with their own municipal infrastructure limitations.
So the plastic we thought we were diligently recycling in North America or Europe often ended up in foreign landfills or unregulated open-air incinerators or just washing into rivers and oceans halfway across the world.
That is the tragic reality. The traditional system was built on a totally linear model. Produce, consume, discard. We have to redefine the very concept of a circular economy. It's no longer about managing waste better at the end of the pipe. It's about shifting the entire paradigm to the beginning of the pipe. Design, reuse, recover, regenerate.
Here's where it gets really interesting. If the global waste network is fundamentally broken, and mechanical recycling is essentially a band-aid, who is actually building the new system? Because this isn't just a theoretical academic debate anymore. The environment is collapsing, but the economy still needs materials.
We do still need them. We can't just stop manufacturing overnight.
Exactly. Which brings us to the high-tech, industrial solutions that are emerging right now, particularly in Europe. It's like we are trying to initiate a massive global software update for physical manufacturing.
I love that analogy. And this is the critical pivot in the global narrative.
Yeah.
We are moving from the grim reality of the problem to the incredibly dynamic frontier of the solution.
Yeah.
And it's vital to understand that this transition is no longer just an environmental crusade led by activists.
No, the big players are involved now.
Yes, it has become an issue of core economic survival for the world's largest industries. Corporations are being driven by incredibly strict new government regulations, massive ESG commitments, environmental, social, and governance standards, and intense pressure from institutional investors.
Right, because the money dictates the action.
Absolutely. BlackRock, Vanguard, the massive sovereign wealth funds, they now view the current linear fossil fuel-dependent model as a major financial risk. If a company relies on single-use virgin plastic, they are vulnerable to future carbon taxes, supply chain shocks, and huge consumer boycotts.
And Sweden has deliberately positioned itself as the international vanguard for this kind of sustainability and environmental innovation, haven't they?
Very much so. Sweden has a long-standing, almost cultural reputation for advanced waste management. I mean, for years, they've relied heavily on waste-to-energy plants, literally burning their trash to heat their homes during the freezing winters.
Which is clever, but not exactly a long-term climate solution.
Right. Even the Swedes are recognizing that simply burning waste for energy releases carbon, and mechanically recycling it isn't enough to meet future climate goals. The pressure to completely decarbonize global supply chains is just too high.
So what are they doing instead?
So you have this deep, highly funded ecosystem of engineering and sustainability companies in Scandinavia leading the charge. Organizations like AFRY, which is this massive European engineering, design, and advisory company, they are at the absolute forefront of this. They aren't just making incremental changes. They are deeply involved in what we call plastics to biotransitions and molecular material innovation. They are the architects attempting to rewire the factory.
All right, let's get into the weeds on this. Explain plastics to bio. What does that actually look like in a laboratory or a manufacturing plant? Because when I hear bioplastic, I just think of those terrible paper straws that dissolve in your drink.
Right, the soggy straw. But no, it's so much more advanced than that. Plastics to bio is the advanced science of moving away from fossil fuel-based polymers and engineering entirely new materials derived from renewable biological resources. Engineers are looking at things like lignin.
Lignin, what is that?
It's the natural organic polymer that makes wood rigid. The timber and paper industries produce millions of tons of lignin as a waste byproduct every single year. Companies like AFRY are working on engineering that lignin into carbon fibers and bioplastics that mimic the exact beneficial properties of synthetic plastic, the durability, the flexibility, the moisture resistance, but with a material that can actually degrade safely in the natural environment.
Oh, wow. So they're taking waste from one industry and using it to replace plastic in another.
Exactly. Or it can be fed back into a biological cycle.
Yeah.
They were looking at nanocellulose. They're looking at PHAs, which are plastics produced naturally by bacteria fermenting organic waste.
But wait, what about the millions of tons of synthetic plastic that already exist? We still have a demand for materials that bioplastics can't entirely replace yet, right?
Right. And that is where AFRY and the broader ecosystem are heavily involved in the other side of the material transition, specifically chemical recycling.
Yeah.
If mechanical recycling is a photocopy, chemical recycling is like having the original digital file. You can print it perfectly forever.
Okay, wait, I need to push back on this.
Go ahead.
Chemical recycling sounds great on paper, but hasn't it been heavily criticized by environmentalists for being incredibly energy intensive? Usually it involves pyrolysis, literally superheating the plastic in the absence of oxygen to melt it back down into oil or gas.
Yes, that's correct.
So aren't we just trading a plastic waste problem for a massive carbon emissions problem? If we are burning huge amounts of energy to run these chemical plants, we are just accelerating climate change to get rid of some plastic.
That is an excellent, crucial pushback. And it is exactly the debate happening at the highest levels of industrial engineering right now. You are absolutely right. Pyrolysis requires temperatures of over 400 degrees Celsius.
Which takes a ton of power.
Yes. If you power a chemical recycling plant using a coal-fired energy grid, your carbon footprint is atrocious. You go backward environmentally. The math just does not work. However, this is exactly why this innovation is thriving in a place like Sweden.
Because of their energy grid.
Precisely. The viability of chemical recycling is entirely dependent on the energy grid it sits on. Sweden's grid is almost entirely powered by hydro, nuclear, and wind. When you apply renewable clean energy to power the pyrolysis process, the entire equation flips.
Ah, I see.
You are able to take complex, multi-layered plastics, like a potato chip bag that has plastic and aluminum fused together, which is completely impossible to recycle mechanically, and break it down to its base molecular hydrocarbon level. You revert it back to a virgin quality monomer, and then you can rebuild it into a brand new food-grade plastic without losing any structural quality at all.
That makes total sense. The technology only works if the systemic foundation, the energy grid, is also green.
Precisely.
Yeah.
But beyond the chemistry, there's also the logistical engineering. Like, how do you separate the massive tidal wave of waste efficiently enough to feed these chemical plants? Humans cannot sort trash fast enough.
Yeah, standing in a conveyor belt, it's impossible.
So we're seeing the integration of AI and machine learning in sorting facilities. Engineers are deploying near-infrared spectroscopy combined with AI vision systems. As a conveyor belt of garbage flies by at incredible speeds, the AI can literally see the chemical signature of the plastic. It knows the difference between a PE beverage bottle and an HDPE detergent jug. Furthermore, the AI can recognize the shape of the item. It knows that a crushed water bottle used to hold food, but a similarly shaped bottle of motor oil did not.
Which is crucial for food-grade recycling, right?
Exactly. It can separate food-grade plastic from non-food-grade plastic instantly using robotic arms and these precise blasts of air.
When you look at what these engineers, chemists, and AI developers are doing, you realize a fundamental truth about our economy. Waste is simply a design failure. If a product ends up in a landfill or an ocean, it wasn't designed properly for the system it lives in.
If we connect this to the bigger picture, the implications of that software update go far beyond just having cleaner parks and oceans. Future geopolitical stability will depend on resource independence.
Because countries won't need to import as much oil?
Right. If a country can mine its own waste through chemical recycling, rather than relying on imported fossil fuels from volatile regions to make virgin plastic, that is a massive strategic advantage. The future of global construction relies on sustainable composite materials. Our food systems depend on advanced packaging that protects against spoilage without leaching forever chemicals into our bodies. Every single sector of the modern economy is waiting for this molecular update to be installed.
So we have these brilliant minds in sterile, high-tech engineering labs in Scandinavia mapping out the molecular future of materials. They are solving the math. But let's ground this. Let's travel away from the labs and look at the physical reality.
Yes, we have to look at the front lines.
Exactly. Because the stakes of this transition are not just happening in boardrooms and laboratories. We have to look at the visceral frontline reality of coastal ecosystems, where this isn't an abstract engineering or financial problem. It's a matter of daily economic and biological survival.
The contrast is absolutely vital. You cannot understand the urgency of the Swedish laboratories until you leave them and stand on a coastline in places like Tulum, Mexico, or parts of the Dominican Republic.
Right.
When you are standing on those beaches, the crisis is immediate, tangible, and just overwhelming. You are looking at the visual, compounding reality of decades of linear economic failure washing up at your feet.
It is devastating. You have these world-renowned, pristine coastlines that drive the entire economy of these regions through tourism. And they are now constantly battling waves of international plastic pollution washing ashore. It's not just local litter, it's bottles with labels from 20 different countries carried in by the ocean currents.
It's the global dump site.
Yeah.
Yeah.
And in places like the Caribbean and the Yucatan Peninsula, this plastic crisis is compounding with massive sargassum blooms.
Yes, the sargassum crisis is a perfect, tragic example of interconnected environmental failure. Sargassum is a type of brown macroalgae. Historically, it floated out in the Sargasso Sea and provided a crucial habitat for marine life.
It wasn't originally a problem.
No, it was entirely natural. But over the last decade, we have seen the explosion of the Great Atlantic Sargassum Belt. It is this massive bloom of seaweed stretching all the way from West Africa to the Gulf of Mexico.
And why is it blooming so aggressively all of a sudden?
Because of us. It is feeding on nutrient runoff. Massive amounts of nitrogen and phosphorus from agricultural fertilizers washing out of the Amazon and Mississippi rivers into the ocean. Combine that nutrient soup with warming ocean temperatures due to climate change, and the sargassum just grows exponentially.
And when it washes up on the beaches of Tulum, it creates an environmental and economic nightmare. I mean, it piles up several feet high. As it rots in the sun, it consumes the oxygen in the shallow water, killing the local marine life.
It creates completely dead zones.
Right. It suffocates sea turtle nesting grounds. And it releases hydrogen sulfide gas, which smells like rotting eggs and can cause severe respiratory issues for the local community. Tourists obviously refuse to visit beaches that smell like a sewer and are covered in rotting weeds and microplastics. The local economy gets totally crippled.
And this is where the conversation on the front lines is rapidly evolving. For a long time, the response from local governments and the hospitality industry was simply mitigation through cleanups. Send hundreds of people out with wheelbarrows and plastic bags to collect the trash.
Which is just exhausting.
It is. Send heavy diesel tractors to scoop up the sargassum and dump it in an inland landfill, which often just causes the heavy metals and nutrients from the rotting seaweed to leach into the local freshwater aquifers anyway. Communities are realizing that cleanups are a Sisyphean task. It is a Band-Aid.
So how does a community actually move past mitigation? How do you transition to regeneration? Because regeneration sounds like a great buzzword, but is it fundamentally different from traditional conservation? It sounds like we aren't just trying to put a fence around the environment, we're actively trying to regrow the ecosystem. But how do you do that when thousands of tons of toxic seaweed and plastic are arriving every single week?
The distinction is crucial, and it requires incredible local ingenuity. Conservation is about pausing the damage, drawing a line and saying, do not touch. Mitigation is about reducing the harm that's already happening, like the beach cleanups.
Right.
But regeneration is about actively participating in the healing process and turning the threat into an economic engine. In these coastal communities, this means combining community-led action with sustainable economic development. It's about regenerative tourism.
Walk me through what regenerative tourism actually looks like on the ground in a place like Tulum.
It means the presence of visitors and local industry actually funds the protection and restoration of the environment, rather than depleting it. Let's look at the sargassum and plastic. Instead of letting it rot on the beach, local innovators and specific eco-conscious hotel groups are deploying specialized boats to harvest the sargassum in the shallow water before it ever hits the shore.
So they intercept it.
Exactly. They bring it inland and process it. They extract the heavy metals, and then they mix the organic biomass of the seaweed with local limestone to create structural building blocks, sargassum bricks.
You're kidding. They build with it.
They do. They are literally building new, sustainable hotel structures and community housing out of the invasive algae that is trying to destroy their coast. Others are putting the sargassum into anaerobic biodigesters to create biogas, which then powers the hotel's kitchens, replacing imported propane.
That is incredible. It's turning the problem into the localized solution, taking that waste, taking that sargassum, and building a microcircular economy. And the profits from that regenerative tourism go back into coral reef restoration projects and protecting the mangroves.
And this is the critical synthesis of our entire discussion today. The community leader in Tulum dealing with the tide of ocean plastic and sargassum is directly, inextricably linked to the design choices made in a corporate boardroom in Europe or North America.
They're fighting the same battle from different sides.
Exactly. The chemical engineer at AFRY in Sweden, developing a biodegradable alternative to multi-layer packaging or perfecting AI sorting algorithms, is directly impacting the future resilience of that Mexican coastline. The systems are not isolated, the laboratory and the beach are completely tied together.
Which is such a powerful realization, but, it also highlights a massive glaring gap in this entire movement.
Right.
We have the brilliant technological solutions and the systemic engineering happening in places like Sweden, and we have the absolute existential stakes in the frontline regeneration happening in places like Tulum.
Right.
But how do we bridge the gap between those two worlds? How do we get the general public, the policymakers who write the laws, and the institutional investors who control the trillions of dollars of capital to actually care, and more importantly, to act and deploy that capital?
That is the single greatest hurdle of the sustainability movement today. It is not a technological hurdle anymore. It is a communicational and behavioral challenge. We have mountains of brilliant ESG reports. We have endless sustainability impact studies detailing Scope 3 emissions and polymer degradation charts.
But nobody reads them.
Exactly. They fail to move the needle at the pace required. Why? Because they are often so highly technical, so overly corporate, and so bogged down in granular data points that they become emotionally disconnected from human reality. You can hand a fund manager or a politician a 200-page PDF on the thermodynamic efficiency of pyrolysis, but it will not change their behavior. Humans are not moved to paradigm-shifting action by spreadsheets.
It's like trying to explain the magic of the internet to someone using only raw binary code. You can show them the zeros and ones all day, but they won't understand what it actually means to send an email to a loved one or make a video call across the globe. You need a user interface. It seems to me that documentary storytelling is essentially the emotional UI for the circular economy.
That is a perfect encapsulation. This raises an important question. How does society actually adopt new paradigms? Throughout history, from the labor movements to civil rights to environmentalism, it hasn't been through data alone. It has always been through narrative.
Stories are what connect us.
Exactly. Narrative psychology shows us that humans understand their place in the world through stories. A well-crafted documentary film can take this incredible, daunting complexity and humanize it. It takes the invisible systems, the opaque shipping routes, the murky global waste trade, the microscopic molecular engineering, and makes them visible and visceral.
And there is a documentary project currently in development that is doing exactly this. It is physically tracing this exact route we've been exploring today. It starts in the cold, precise innovation hubs of Sweden, looking at the high-tech solutions and the brilliant minds trying to rewrite the material code, and it travels all the way down to the warm, embattled coastlines of the Caribbean and Mexico, looking at the local innovators fighting on the front lines to regenerate their homes.
The power of that kind of storytelling is that it activates empathy and accelerates awareness. When an investor or a policymaker can see the face of the engineer designing the new material, hear the passion in their voice, and then cut to the face of the community leader restoring a dying reef in Mexico, the data becomes real.
It's not just a chart anymore.
Right. Mirror neurons fire. It fosters collaboration across industries that normally never speak to one another. Suddenly, investors aren't just looking at ESG as a tedious compliance checklist or a marketing buzzword. They see the human and environmental stakes of the transition. Storytelling has the unique ability to collapse geographical distance, connect disparate realities, and create the cultural and behavioral shifts required for these new systems to secure funding and actually take root.
So what does this all mean for us? We've covered an immense amount of ground today. We've seen that the future of plastic, and really the future of our entire material world, isn't going to be solved by just one silver bullet.
Not at all.
It requires this incredibly intricate blend of stringent global policy, cutting-edge molecular engineering, like the plastics to bio and chemical recycling work happening at AFRY, and it requires regenerative, community-led action on the front lines. And binding it all together is the power of human storytelling to make us care enough to fund and support these transitions. It really is a story of humanity being forced by our own success to reinvent the systems that keep us alive.
And it reminds us that the material of plastic itself is not the inherent enemy. It is just a polymer. The true challenge is our own design philosophy. How do we design production, consumption, reuse, and ultimate responsibility? The choices being made right now by these innovators in Scandinavian labs and these communities on Mexican beaches are going to shape the health of our oceans, the structure of our global industries, and the resilience of our societies for generations to come.
I want to leave you with one final thought to mull over today as you go about your life. If we truly embrace this idea that waste is simply a design failure, and we successfully implement this chemical and biological software update for manufacturing, what happens to the past? Will future generations look back at our sprawling, toxic landfills, not as tragic trash heaps, but as poorly organized, highly concentrated mines of incredibly valuable raw materials just waiting to be intelligently recovered? Thank you for joining us on this deep dive into the source material. I encourage you to look at the physical objects around you today, not as permanent trash, but as molecules waiting for their next life. Until next time.